Applying the Java plugin is simple. We only need to add a single line to our build script. Now if we run Gradle Tasks, we see a whole wealth of capabilities that the Gradle Java plugin can handle for us. There are 4 main tasks we'll use most often: assemble, build, clean, and scrolling down a bit, we'll use the test task as well. Assemble creates the output we're interested in. This is usually a jar, but can also be more interesting artifacts. Check runs any tests we've set up. Build depends on both assemble and check. Finally, clean deletes all the build output. We've got a trivial Java project in this folder with a single class called person. Let's try running Gradle assemble. Looks like it's done. Looks like the build directory contains another 4 directories. Looking in the newly created build directory, we find a classes subdirectory, which holds our compiled classes, and a lib subdirectory, which holds our newly created jar. Now you might be thinking to yourself, I thought there wasn't going to be any magic. This sure seems like magic. How did Gradle know where to find my source code? I promise there's no magic. Gradle just has a lot of very sensible defaults. Like, for instance, it assumes that your Java sources live in a folder named source main Java. This, like most everything else in Gradle, can be configured, and we'll show how shortly. There's another important thing to know how to do, and that's run the project we just built. You might have noticed that the Java plugin doesn't add any tasks for running your code, and that's because the Java Exec task type is already part of the core Gradle functionality. The main property tells the Java Exec task the path of your main class, and we'll talk about this class path property very shortly. If we go ahead and run this task, there we go. We see our task running, and then we see a greeting coming from our newly compiled Java.